Welcome to FEMSA Edu Consultancy channel. Today we'll be looking at matrices question from Jupeb past question. So we have 2015 and 2019 last year. So for 2015, we have question 1 was on matrices. The question says find the non-zero negative value of x which satisfies the equation, this equation. Okay, so solution. What this equation is saying is that the determinant, that symbol, that modular symbol indicate determinant. The determinant of this 3 by 3 matrix, that's the order of the matrix, because we have how many rows? 3 rows. 1, 2, 3. How many columns? 1, 2, 3. There are 3 columns. So 3 by 3 matrix. So the determinant of this 3 by 3 matrix is 0. How do you get the determinant of this 3 by 3 matrix? The determinant of a square matrix is just the sum of the product of each element, or the sum of the product of the element in any row or any column. Sorry, what did I say? The determinant of a 3 by 3 matrix is the sum of the product of the element and their corresponding cofactor along any row or any column. But I know the one you are used to is the first row, and we'll make use of that. But you can still get the determinant of this matrix using any of the 3 rows or any of the 3 columns. You will still get the same results. Okay? Now, what does this imply? X 1 0 1 x 1 0 1 x. All right. This is objective question. Feel free to use any approach that you like. All right. So I'm taking this now. Don't forget I said the determinant of a square matrix or determinant of this 3 by 3 matrix is the sum of the products of each element along any row and their corresponding cofactor. All right. So I'm picking row 1 now. For row 1, what are the elements in that place? X 1 0. So if I can get the cofactor of x, I will use that cofactor of x to multiply this x, get the cofactor of 1, multiply 1 by its cofactor, get the cofactor of 0, multiply it by this 0. Whatever I get for those results, add them together, that will give me the determinant of this matrix. That thing I just said, that means I can get it using this column, 0, 1, x. Or I get using this row, 1, x, 1. I will get the same result. Because all that we need to do is get the cofactor of all the elements along any row or any column, multiply multiply each element by their corresponding cofactor and add them together. That's the determinant. All right. Now, so I'm picking this now. The next question is that how do I get the cofactor of an element along any row or any column? It's very simple. The cofactor is just a sign attached to the minor of that element. How do I get the minor? See the way I'm just complicating matter. But yeah, look at it. For the minor of x, look at it. Close up the row of x, close up the column of x. When you do that, what do you see? You see x 1 1 x. That's a 2 by 2 matrix that you see. Okay, now that 2 by 2 matrix that you have seen, all right, is the determinant of that 2 by 2 matrix is the minor of x. But x itself in the arrangement or the position of the element of x in this matrix is in what? X is occupying the first row and the first column. That position is position 1, 1. 1 is occupying what position? First row, second column. 1 is in position, is like A, the x is like A1, 1. 1 is like A1 sub 2, A sub 1, 2, sorry, and 0 is like A3, 1 sub 3. That means first row, third column. This question is not difficult to solve. I'm just trying to explain so that in case you come across any other question you apply, you don't just cram. Try to understand this concept. So this position 1, 1 or 1, 1, 1, 2, 1, 3, if you add up those positions, if you add this together, you have what? 2. Add these positions together, you have 3. Add these positions together, you have 4. Alright? You will notice that if you do that for 1x, 1, 0, 1x, alright, it will help you to know this one now is in the second row but first column. That's position 2, 1. Add it together, you get 3. This x is in the second row and second column. That's position 2, 2. Add the 2, 2 together, you have 4. 1 is in the second row but third column. That's position 2, 3. Add it together, you have 5. So anytime the position is, anytime the sum of the position gives you an even number, then you attribute a positive sign to the minor. The moment you attribute a positive sign to the minor, that automatically gives you the cofactor. Are you getting it now? Now, if it is an odd position, that means odd number, when you add up the positions together, then attribute a negative sign to the minor of that element. Once you do that, the result gives you the cofactor. It's as simple as that. Alright? That means that the difference between minor and cofactor of an element of this matrix is just sign difference. Okay? Once you attribute a sign to the minor, you get cofactor. It's as easy as that. Alright, so now, but to save my time, I could have used any element here. I will get the same results. But because this is a 3 by 3 matrix, when you close up any row and any column, the next matrix you will see is a 2 by 2 matrix, and you need to find the value of that 2 by 2 matrix, and that's what will make you get the determinant. Alright, so here you see this plus, minus, plus, they always write. I know you have crammed it. That plus, minus, plus is as a result of that position. Okay, so that means if I'm to use this one, the sign will be minus, plus, minus. That means if I'm to use this one, it will be plus, minus, plus. That means if I'm to use this column, it will be plus, minus, plus. It means if I'm to use this position, it will be minus, plus, minus. And if I'm to use this position, it will be plus, minus, plus. Do you see it now? Don't just cram. You can go and try it on your own, and you see that you get the same result. So, but let's use the conventional way that you are used to. Alright, so this is equal to 0, right? Okay, but what is the value? This is my x. Look at it. This positive sign is already here, so I don't need to put it. Then once I close up the row and the column, what do I see? I will see another 2 by 2 matrix. I need to get the determinant of that, which is x, 1, 1, x. Do you see this now? Then this negative sign came as a result of that. Normally it is plus, look at it, so that you see where it's coming from. Plus 1 multiplied by the cofactor. Look at, I'm using a bracket. The cofactor of 1 is going to be minus the determinant of the matrix you will see when you close up the row and the column of 1. When you close up this row and this column, you will see 1, 1, 0x. 1, 1, 0x. Do you see it now? Then plus. But instead of going through this stress, this minus sign will multiply this plus sign eventually, and that's why you will always see it reduced to minus. That's where that minus is coming from. Okay, not as though we just put minus here. So you have 1, then I know that this is now going to be 1, 1, 0, x. Alright, then you have plus. I know that will be addition with this plus, it will still be addition. So when you close up the row and the column, you see 0, this is 1, x, 0, 1. Then all this will be equal to 0. Now, once I believe that you should have read up this topic, we are just trying to solve as many questions as we can lay our hands on. It is expected of you, because this is objective question, you are not to spend longer time the way I'm analyzing, alright? So you can just quickly glance through the question. Of course, the moment you have to get determinant, see, once you are using a particular row and you identify one of the elements of that row to be 0, just know that the result of that particular part will be 0. There's nothing you can do about it. Like this one now. Once I pick this, I don't bother myself to pick this, because I know the result I will get from this part will be 0. It's like 0 multiplied by what? Whatever you get here will be 0. That means that if I'm to solve this thing within few seconds, the number I'm only going to consider is just this and this. Do you understand it now? But just for you to get it, that's why I'm going explicit. Alright. Now, can we expand? This x, this is it. Can we get the determinant of this 2 by 2 matrix? Yes. All you just need to do is the same way, but they've taught us the fast approach. Multiply the element along the principal diagonal minus subtract the products of the element along the minor diagonal from it. So x times x will give you x squared minus 1 times 1 is 1. Do you understand? But that minus sign is as a result of what I just said earlier on. This one occupies the first row, first column, attribute a plus sign. This one occupies the first row, second column, attribute a negative sign. That negative sign from that place, once you close up the row of this and you close up the column, you will see only x. That x is the minor of this x. The moment you put the sign of this position to this x plus x, then that becomes the cofactor of x. That means the cofactor and the minor of this x are the same. But check this one. Close up this row, close up this column. What do you see? 1. The 1 that you have seen is the minor of this 1. The moment you attach the position sign of 1 to that minor, what will you get? You get minus 1. That means the minor of this one is 1, but the cofactor of 1 is minus 1. So if I go by what I've told you, that the determinant of a matrix, okay, is the sum of the product of the elements and the corresponding cofactor along any row or any column. That means if I pick this x, I have x, multiply it by the cofactor. The cofactor of x is x. I'm adding it to 1. Multiply by its cofactor. The cofactor of 1 is minus 1. Once you do this, what do you have? X squared, or you still leave it as x times x. This plus times minus is minus, then you have 1 multiplied by 1. It is this one they generalize that made them to be always saying, oh yeah, multiply this by this, subtract it from this by this. It's because they don't want to stress us. I don't know. Okay, but just know so that you don't stick to that. Means I can still get the what? The determinant of this using any other. Okay, I can decide to use these two, I can decide to use these two, I will get the same result. But because it's a 2 by 2 matrix, whichever way you do it, you will always result to something of this nature. Okay, alright, so that's just that. Then I have from here, I'm going to have minus 1. I do know that 1 times x will give me x minus, okay, I'm just going straight now. 0 multiplied by 1 will give me 0. And of course, you know this one will give us 0. So equal to what? 0. Alright, can I open up the brackets? This will give me what? S cube minus what? Minus x. What will this give me now? This x minus 0 is x times 1 minus x. This is equal to 0. This will give me s cube minus what? 2x equal to 0. Something is common, right? X is common. Factor it out. What do you have? X squared minus 2 equal to 0. The product of these two real numbers gives us 0. What does that imply? It means one of them must be 0. So it is either this implies that x is 0 or x squared minus 2 is 0. Don't forget the question says that what? Find the non-zero negative value of what? X. I've already gotten 0. I don't need this. It has already told us non-zero. Alright? So this cannot be the answer. I'm coming for this. So look at this. This will become x equal to s squared equal to 2. And if s squared equal to 2, what is x? That means x will become square root of 2. But is it just square root of 2? That's plus or minus. Wow. Find the non-zero negative. If it is non-zero negative, that means plus root 2 cannot be the required value. So the required value is going to be what? Minus root 2. So the non-zero negative value of x is minus root 2. That's option D. Alright, this is another question. The same year, question number 2 is an objective question. Once you observe that you are given an objective question, that shows that the number of steps you have to take is not as long as it appears. Okay, except you have to be fast in your calculation. However, there might be some shortcuts. Okay, like in this question now, I'm only going to take one step and we'll see our results. And we'll now compare it with the conventional approach of the one we are used to. Alright, that's because this question is just peculiar. It doesn't really mean that it may be that easy. But I spotted something here and I think it will make me solve this question within few minutes. Alright, so solution. So my solution to this question basically is what? Look at it. And to find the determinant of z. So the determinant of z is going to be this. That's the symbol for determinant. And this is going to be this 2, 3, 3, 4, 1, 0, 1, 4, 0. So what is the determinant of this? The result is going to be equal to 3 multiplied by 4, 1 by the determinant of this. And this will give me 3 into 16 minus 1. And that's 3 times 45. Yay! Sorry, I made a mistake. That's 3 times 15. And that is 45. That's option B. This is how fast it is. I know that when you want to do it, you have the tendency of following the general conventional way of saying, okay, plus, minus, plus. Now, that's why I said earlier that you need to know that the determinant of a matrix is the sum of the product of every element and their corresponding cofactor along any row or any column. Do you understand what I said? Take any element, multiply that element by its cofactor. Okay? Now, take any row or any colon. In this kind of case now, we have, this is a 3 by 3 matrix. So we have 3 elements along a row. Now pick any of those elements, get their corresponding cofactor, multiply those pairs and add them together. You will see that the result is going to give you the determinant. Now see what I spot or I saw, alright, that made me solve this in how many lines. I just saw, don't forget I said in the other question that once any element along any row or any column is 0, the product of that part will always be 0. So inside this place I can spot 0, 0. Yes, I can jubilate because I don't have to bother myself with the element here. I know that once I take this element and their corresponding cofactor and I multiply them, I will surely get 0. So the determinant is just only these 3 multiplied by the cofactor. Do you understand now? And I know that this 3 is occupying position what? 3, 1. And that means some of those positions is 4. So it has a positive sign to be given the cofactor. So I don't need to worry myself. So close up this row and the column of 3. What do I see? 4, 1, 1, 4. Get the determinant of that 2 by 2 matrix. Attribute a plus sign to it. That's the cofactor. The determinant of this 2 by 2 matrix is what? 4 times 4, 16, minus 1 times 1. That's 1. That's 16 minus 1 is 15. So 15 times 3, that's the determinant of this matrix. Do you see how fast it is? Now let's use the conventional way that you are used to and let's see if we get the same result. Alright? It's just that one will take you longer time. Alright, so we pick this 2 multiplied by the cofactor. So what element do you see when you close up the row and the column of 2? You see 1, 0, 4, 0. 1, 0, 4, 0. Alright, then you have minus, then you have 3. The same way, close up the row, close up, what do you see? 4, 0, 1, 0. 4, 0, 1, 0. Alright, then the other one is plus 3. What do you have? Close up the row of 3. What do you have? You see what? 4, 1, 1, 4. Do you see something? I already know too that this will give me 0 because by the time I multiply this 0 and this will be 0. So I have 0. This will also give me 0. Then I have 3, 16 minus 1. This is 3 times 15. This is 0. And that's what? 45. That's it. No. So the step of taking all of these is another longer step. Alright? If you are fast too, this is also okay. If you know what you are doing, what you just need to do is ensure that you don't make mistake in your multiplication. But I think that because I spot this one now, until you do it, until you try to do the multiplication, you may not quickly see that you could get 0 as part of the cofactor. But from this side, I can see clearly that I will definitely get 0 upon my multiplication along this column. So for these 2 elements. Hope it's clear. Alright. So this is a theory question now. It's a theory question. So you have to be explicit here. You can't rush and do wuru. Okay. So evaluate the determinant A. That's the determinant of A now, where A is this value 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so and we Roman figure 2 we are to conclude from our results. Alright, so now look at the solution. So determinant of A is this. This is the determinant of A. So this will give us, don't make mistake to make it bracket to 1, 2, 3, 4, 5, 6, 7, 8, and 9. don't make it matrix. It's not matrix again. You want to find the determinant. So what will be the result of this? Of course, I do know that you. Let's use our normal, as in the method we are used to. So using the first row, element along the first row. So 1 multiplied by, once you close up the row of 1 and you close up the column, what do you see? 5, 6, 7. 5, 6, 8, 9. That's the matrix we'll see. So it's a 2 by 2 matrix. 5, 6, 8, 9. Then minus 2. Close up the row and the column. What do you see? 4, 6, 7, 9. 4, 6, 7, 9. Then 3 plus 3. Close up the row and the column. What do you see? 4, 5, 7, 8. 4, 5, 7, 8. Alright, so can we do our multiplication? You have to be very, accurate in your multiplication. 5 times, this is 1. Okay, so you may not necessarily bother yourself because 1 multiplied by this will still be that result. So 45 minus what? 48. 8 times 6, Abi. Then minus 2 into 4 times 9. Now 4 times 9, 36. Okay. Minus, what about 7 times 6? Okay, 42. You are correct. Plus 3. What is 4 times 8? 32. Minus, what about 7 times 5? 35. You are correct. Alright, so we can subtract. This is going to give us minus 3, Chibi. Then minus 2 into, subtract this. Is that not minus 6? Good. Plus 3 into, is that not minus 3? Good. So what would this one give us? Minus 3. This will give us plus 12. This will give us minus 9. So what is minus 3 plus 12 minus 9? I think that's 0. Good. Alright. So at the end of the day, since the determinant of this matrix A is 0, what's our conclusion? Then you remember, whenever the determinant of a matrix gives 0, that means that matrix should be a singular matrix. Yes, you remember now. Good. So our conclusion for Roman figure 2 says, what do you conclude from 2A? Hence, our dear Momo, you understand now. You know the plural of n is hence, Abi? Don't mind me, I was joking. Alright, so hence hence matrix A, or you can just say hence A is a singular matrix. You get that? Alright, this is another question. This last year's Jupeb question, 2019 question number 13. There was no question in theory, so on matrix. This is just an objective question. It says if P is a 3 by 3 matrix such that the elements are y3, 0, 2, 1, y this, what is the range of values of y for which the determinant of P is greater than 0? You understand now? So look at it. That means find the determinant of P, then introduce inequality greater than 0 to it, and find the range for which that determinant will be greater than 0. Alright? So that means that determinant of P greater than 0, this implies that what? Matrix P, y 3, 0, 2, 1, y, 2, 1, and 2. This will be greater than 0. Alright? So now, what do we do? Let's apply. See, for me, because it's theory, let's just use the normal approach. But you know that because I have one of the elements to be 0 here, definitely that's the product I'm going to have along that 0 will be 0. So I don't need to worry myself. So but let's just go ahead with it. So picking this first element y now, y multiply by the determinant of the 2 by 2 matrix we will see when we close up the row and the colon of y. So this will be 1y 1 2, 1y 1 2. Then the cofactor of 3 will definitely be negative, so minus 3. Then the matrix of 10 will be 3 2 2 2 when you close up the row of 3 and the colon of 3. That will be 2y 2 2. Then the third one, just for formality, that's why we are writing, but I know it will be 0. Plus 0, close up the row and the colon, you see 2 1 2 1. This will, the result will be greater than 0. Alright, so now this will give me y. What's the determinant of this 2 by 2 matrix? 1 times 2 minus 1 times y. That will give me what? 2 minus y. Minus 3 into 2 multiplied by 2 is what? That's 4 minus 2 times y. That's 2y. Then I know this will be 0. You get that? You don't need to bother yourself. Okay, plus 0. Then greater than what? 0. Now open up the bracket. You have 2y minus what? Minus y squared. This is minus 12. This is plus 2y. Yeah. Plus 6y. Sorry, I made a mistake. Greater than 0. Alright. Can we collect like terms? Yes, we can. What do we have? 2y and 6y will give me 8y. So I have, look at this. Minus y squared. 2y plus 6y is 8y. Then I have minus 12. This is what? Greater than 0. To make life easy for us in solving this problem, not that we cannot solve it like this, try as much as possible to make the variable with the highest power, make the coefficient to be positive. So I'm having coefficient of minus 1. I want it to be positive. So all I need to do is multiply every element in this inequality by minus 1. I hope you know, mind you, that whenever you are multiplying with a negative sign in an inequality, the sense of the inequality will be reversed. I hope you know that. So which means that when we multiply, that multiplication, I'm going to use it by implication. I only told you what I am doing, alright, or what I intend doing. It implies the moment I multiply by minus 1, this will become what? Y squared. Multiply by minus 1, you have minus 8y. Multiply by minus 1, you have what? Plus 12. Then this is going to be reversed. The sign will be reversed. Less than 0. Please, I want you to know that what you are... Yay! I forgot something. I was distracted. I thought I was doing theory. Because I was not doing theory, I need not to have written this. Okay, because I already know it will give me 0, so it is going to waste my time in writing it, because this is an objective question. I need to be very fast. So this is just these 2 that is required of me to save time. And the moment I get here, see, once you have a quadratic inequality and you notice that the variable with the highest power is positive, once the sense of your inequality, or the inequality sign rather, that you can see here is less than 0, your result is going to be within a range. Will I call it like an enclosed range? Are you getting it now? Like this now in between two values, yes. But if it were to be greater than 0, that means your solution will diverge. As in, how will I put it now? Your solution will not be enclosed within two numbers or within boundaries. Okay, so in this case now, if I want to solve this problem, I solve it as if I'm solving quadratic equation. But because of this less than 0, I know that my result will be between two boundaries. Alright, let me just show you the shortcut, but we'll now solve it step by step. Now, imagine that this thing is equal to 0. What do you think will be the solution of this quadratic equation? You know we have to find factor. So we think of two factors of what? Plus 12y squared. You know you are multiplying the first term and the last term together. Once you do that, you get plus 12y squared. Now, we have to find two factors of that plus 12y squared such that their product will give us plus 12y squared and their sum will give us minus 8y. And if you look at it closely, you will see that it is minus 2y minus 6y. Ignore the letter. That means minus 2 minus 6. Minus 2 times minus 6 is plus 12. Minus 2 minus 6, is it not 8? I mean, it's not minus 8, minus 8. The moment you have gotten your factor, don't do anything again. Just reverse the sign. Minus 2, reverse the sign, you have plus 2. Minus 6, reverse the sign, you have plus 6. That's your answer. 2 and 6. Oh, so if this were to be equal to 0, if I had solved this equation, I would have gotten 2 and 6. Now, because it is inequality and it's less than 0, so you see that 2 and 6, your result of this inequality will be between that 2 and 6. What I'm saying is that it will just be, that means it implies that 2 is going to be less than y is going to be less than 6. That's all. You see? Now, if this were to be greater than 0, then the result of this will be less than the smallest, greater than the greatest. That means x will be less than 2 or y will be less than 2 and y will be greater than 6. If it were to be greater than 0, that means the result of this will never intersect. But if it is less than 0, you always have your answer this way. That's why I can see that this is not here. So they have even made the work easy for you. Alright, so but the result is going to be 2 less than y less than 6. So which is going to be option B. Okay, but let's see the step-by-step approach to arrive at that answer. So in case you are dealing with a theory question. Alright, so this is less than 0. So we have gotten our factor minus 2y minus 6y. So this is going to be y squared minus 2y minus 6y plus 12 is less than 0. So this now we can group factorization by grouping. Y is common between these two terms. We have y minus 2. Then 6 is common here, minus 6 rather. Minus 6, I've left with y here. Then this will be minus 2. Okay, you factor out minus 6 from 12, you have minus 2 less than 0. What is common between this expression and this expression? You notice that it is y minus 2, right? So this is y minus 2. If you factor it out, what will be left here? You have y left here. What will be left here? Minus 6. So I can group this now. So this is still going to be less than 0. Look at this. How do we now solve this problem? This inequality. Now, the product of these two real numbers is less than 0. Okay? So now, what that means is that less than 0 means numbers that are negative. Abi? So that means if I multiply this by this and it gives me a negative result, what does that mean? It means that one of these real numbers must be negative, the other will be positive. Because it only takes a positive real number and negative real numbers product to give us a negative result. But do I know the one that is negative? I don't know. So look at it. This implies that it's either y minus 2 is the one that is positive, which means greater than 0, and the other one, y minus 6, is less than 0, negative. Or it is this y minus 2 that is less than 0, negative, and y minus 6 is the one that is greater than 0. Now see it, either of these two, we don't know which one, okay? Pardon me to rub out this aspect. So we'll see now that for this one, this will give me, it implies I will have y is greater than 2 and y is less than 6. Add 2 to both sides and add 6 to both sides, or y is less than 0 and y is greater than 6. Now check it. Is it possible y is greater than 2? y is greater than 2 and y is less than 6. If you pick any value here, 3, is it less than 6? Yes. If you pick any value here, for example, say 5, is it greater than 2? Yes. So this will be true. But look at this, y is less than 2 and y is greater than 6. Pick any value here that is less than 2, which is what? 1. Is 1 greater than 6? Oh no. Pick any value here, which is what? 7. Is 7 less than 2? So it is not possible for us to have this, okay? Since it is not possible to have y less than 2 and y greater than 6, then the solution to the inequality is y greater than 2 and y less than 6. So what does that mean? Rewrite this. This means that what? 2 is less than y and y is less than 6. This implies, match them. 2 is less than y, y is less than 6. Do you see it now? That's option B. So I hope you have picked from this video. I encourage you to solve more questions on matrix. We'll still bring you more questions from other practice questions that could be of help in preparation for your Jupeb. I declare that the things that you have learned within this short time that we've done this video is retained in your cerebrum in the name of Jesus. God bless you and do maximize your time.